G'day viewers. In this segment we'll talk about the Socket API, the most widely used interface to write applications on the internet today. Okay, so this figure is providing you with some context to remind you where we're at. We have applications attached to hosts which are using the network. The applications using this interface, the network application interface, to talk over the network. And this interface is really defining how applications can use the network. The purpose of using this API, of course, is to let apps talk to other apps. So that's what apps want to do. They just do this via the local host. And this API should allow them to do this while hiding all of the details of what goes on in the network here, in this cloud, which might be an ISP, for instance. How many routers there are and so forth in that cloud really shouldn't matter to the applications. They just want to talk across the network. So before we dive into the details, here's a motivating application, a simple client-server setup. So on the left here we have a client which is sending this request over the network to a server. The client is actually really a client app or a program running on the host, the client host. And when I say server, I also mean the server app that's running on this host here, which is acting as a server. The server app will receive the request and respond with a reply. This reply could be anything, it depends on our application. The reply will go back to the client app that's running on the client host. This might be a web page, for instance. This is a very simple pattern. However, it's a very important pattern because it's the basis of many different applications which are used on the internet today. For instance, if you just consider file transfer, essentially the request is the name of the file that's sent from the client to the server, and the server app then returns the contents of the file. That's a much longer reply. If we just consider the web browsing case, the request that you're sending is a URL. So you're sending the name of a particular page you would like. And then the response from the server, the reply from the server, is the contents of that web page. And yet another example is simply the simple echo program, where the client is sending a message and the server is echoing it back. This is very useful for test functionality. Well, this is a key application pattern, even though it's fairly simple. Let's see how you would write it. Okay, to write it, we need some concrete API by which the applications running on a host can interact with the network, and that is the Socket API. It's providing us with a fairly simple abstraction that will let us use the network. And as I said before, sockets, that's the API which you use for essentially all internet applications. So this is the one we really want to look at. Sockets were devised long ago. They were part of some of the early Berkeley Unix releases around about 1983. Since then, sockets have become part of all major operating systems, and libraries to access them are present in all major programming languages. Now, all of the details vary a bit from one language to the other and one operating system to the other, but at a high level, they're all different socket APIs, and they all look quite similar. They just differ in a few details. Now, there are two different kinds of network service that the Socket API provides. And the one we're going to look at is called streams. This is a byte stream, and it allows one application to reliably send a stream of bytes to the other application, and vice versa. That's all we'll really use to make our client-server example. There is another kind of network service that's called datagrams, where an application can unreliably send a message to another application. We'll look at this much later in the course, and you can ignore it for now. Okay, so here's one more slightly deeper view of sockets. Now, we've said, so here's the app, and it's running on a host. Here is the Socket API is across here. That's the API between the applications and the network. Sockets use a data structure that are called, unsurprisingly, a socket, to let an application attach to the network. So there's one socket that application's using. An application needs at least one socket, maybe more. And here's another socket that the other application here is using. Sockets also have numbers, what's called a port number. This provides a form of addressing. You can see on the left we have port number 1 on the left socket. The right socket is known as port number 2. These port numbers provide a form of addressing, and that's what allows us to multiplex multiple different applications on a single host because we can distinguish between them. And here, finally, is the API. This table really shows you all of the main API calls that are used for sockets. So let's see what they are. Well, the top one here, this socket call, is what's used to create the socket structure itself, and that helps you create a new communication endpoint that an application can then use to access the network. Okay, what about the rest? Well, there is a send call. That is what an application uses along with its socket structure to send information, actually to send bytes reliably to an application elsewhere across the network. Okay, and you won't be surprised to learn that there's also a receive call. And this is a call which is used by the application at the other side to receive that information that's come across the network from the application that sent it. So it's probably not surprising to you that we have a send and receive call. What's everything else? Well, all of the other calls have to do with setting up and managing connections. When we're talking about streams, they're really analogous to a telephone call. Before you can simply send information across the network, you need to be able to set up a connection, much like making a telephone call to connect and make sure that there's someone at the other side who's waiting to receive your information. So the connect call here is used by one side to establish a connection to another side. These three calls above it, bind, listen and accept, these are calls that are used on the incoming side to get ready and to accept an incoming call. And finally, the last call in this table is the close call. Well, that's what you use to release a connection and hang up, if you like, when both sides are finished. So let's go into a little bit more detail and see how we would actually use sockets. Now, I'm drawing a time sequence diagram here. We have a vertical line for the client, the first host, on the left-hand side, another vertical line for the server on the right-hand side. Time runs down this page. So let's see what happens over time. Well, actually, the first thing we need is some phase when we connect the two different, the client to the server, they connect. And then the client is going to be able to send a request. And we want the server to respond with a reply. And after all of that, much later on, we can close the connection. Both sides can close the connection and we're done. So let me tidy that up a little bit. And you can see this is the sequence of interactions that happen. And I've numbered them in the order in which they would happen on both sides. So connect, request, reply, and disconnect. And you can also see the direction in which messages are going. I've also dotted the connect and disconnect because these are really control operations, things that we just have to do to support the mean data transfer in the more solid line. The data transfer is what we really want the network to do. Well, let's go into this in a little more detail by writing down the different kinds of socket API calls which are used to cause this to happen. So what have I got to do? Well, actually, one of the first calls I need on both sides is a socket call. This is really to set up our socket structures. Then what would we do? Well, the client's going to connect. Oops. Okay, hopefully you can read that. The client connects, and to make that happen on the server side, we need to go through a sequence of calls. We need a bind, accept, listen, and accept in that order. Bind is really, so when we connect, we're going to want to connect to a certain server host on a certain port. Bind is really establishing an address for the communication endpoint. And listen and accept then prepare the socket to accept connections from the other side. And accept is the call which actually results in a connection being made from the other side. Once all of that's done, what are we going to do now? Well, we're going to send our message. That will cause this request to go over. That's what we want to send. We'd better call receive on this side to be able to receive it. After the request has gone across, we're going to want to call send on the server to send back a response. What the response is up to all of the code on the server. It could do anything. It could read a file off the disk, for instance, to get the message to send back. But we're ignoring that because we're just focusing on the use of the network API. On the other side, we'll need a receive call, and then much later on, both sides can call close. So this is the sequence of socket calls which are used both the client and the server to cause this interaction to happen. So let me clean this up. Here we are, and you can see what I've done now is I have numbered the calls in the sequence in which they will happen. Okay, so let's go through this. And you'll note that I've also added a star here. Star indicates blocking calls where the program makes the call and the program is then halted by the operating system until something happens and on the network side. And the network operation completes, and then the program gets the result and can continue. So here's the sequence of operations. On the left-hand side we call a socket. Okay. On the right-hand side we call a socket, and then we go through the bind, listen, and accept. Now, interestingly here, accept is labeled number 4, so it looks like we accept the connection before we make it with step 5. That's because accept is a blocking call. Accept tells the network to wait for and accept a connection. So it's just like telling someone maybe to go and sit by the phone and wait for it to ring. Connect, on the other side, is going to be someone making the call, which will cause it to ring. Eventually, when it causes it to ring, later down here, the program on the server side will continue. Once the server side has picked up the phone with this accept call, what would you do next? Well, if you just picked up the phone, here actually what the program is going to do is it's going to call receive, which is another blocking call. This is really the receiving side simply waiting to receive information. Later, sometime you'll call send. This is after the connectors come back. Then we'll call send. And that will cause this request to go over the network. The receive call, someone is waiting for it. They will then receive it. Now they'll work out what to do, and eventually they'll go back and send it. Of course, on the other side, once we called send, your program has sent the information away. It's going to be received by someone on the other side of the network sooner or later. But without waiting for that, you can go ahead and call receive, which now simply tells you on the other side of the network to now stop talking and instead listen and wait for someone on the other end to say something. Eventually you'll receive the message. That's the reply we've all been hoping for. Then you can get that and display your web page or whatever you want to do. And after that, we can then go ahead and close, and we'll close on both sides. So you can see here I've shown the sequence of calls and note which ones are blocking, because that's sort of affecting the order and the timing of the execution in the program. Okay, so this is really using the socket. All that remains is for me to take these two sides and divide them so that we have separate client and server programs. And here is the client side as we just go through that. And you can see the calls as we go down. We start with the socket. Now there's actually something that you hadn't seen before, something called get_attr_info. This is really just some translation mechanism. You might have wanted to connect to a host called www.example.com on port 80, say. This might be a web server. Well, the network calls, the socket calls, don't take these high-level addresses. They take things like IP address numbers, network addresses. So get_attr_info is translating between high-level names and network addresses. So it's doing some of that bookkeeping. Now, and then we have the sequence of calls in the same order, and we go down here and we really go through just all of the steps that I previously outlined to execute the client program, sending the reply, receiving the message, and doing whatever we want with it. So what about the server? Well, the server goes through the same things. It creates a socket. Here's another get_attr_info to really, for the same reason, to translate between names and any addresses that are needed. Then we go through the bind, listen, and accept calls as before. Now, then we have the usual waiting for a request, sending back the reply, and eventually closing. Often, however, this portion will be in a loop. That's because the client program might exist to make a single connection and get the information back. But often the server will be a long-running process. It will be running, it will wait for a client to connect, and it will service that request, then it will wait for the next client to send a request and service it, and so forth. So there'll often be a loop structure in this program. And that's it. Now we have our client and our server pattern. I want to point out, if you're writing this as code, there's lots of detail that I've omitted here, both in terms of all of the parameters in a program in C or Java or Python or anything you like, as well as all sorts of other code to handle error conditions that could arise if everything doesn't go smoothly. But this is the heart of the program, and you can, by using this pattern, begin exploring your own client-server programs. So now we know something about how to write an application and use the network.